विद्यार्थी मित्रांनो, आजच्या या लेक्चरमध्ये आपण रोटेशनल डायनॅमिक्सचा कन्क्लुडिंग पार्ट एक्सप्लेन करणार आहोत. यामध्ये दोन पॉईंट आपल्याला एक्सप्लेन करायचे आहेत. एक म्हणजे लॉ ऑफ कॉन्झर्वेशन ऑफ अँग्युलर मोमेंटम, which is denoted by L. Now say, by definition of angular momentum, it is given by the cross product of R into P, where R is momentum, P is linear momentum. When we differentiate this L with respect to T, we will get d by dt of R cross T by the law of derivation, derivative of first into the second plus first into derivative of second variable. या लॉ प्रमाणे स्टेप येते. आता यामध्ये dr by dt is nothing but velocity, rate of change of displacement. Similarly, rate of change of momentum is nothing but force. So this equation becomes m into v cross v, because p is the product of mass and velocity, plus r cross f. Now self cross product is equal to 0. Therefore we get the equation dl by dt equal to r cross f. By definition, this r cross f is nothing but torque. So ultimately this dl by dt is nothing but torque acting on body. For no external torque, when we talk about this, when no external torque is acting on rotating body, what happens there? Torque we consider 0. So this equation dl by dt is equal to 0. काय याचा अर्थ होतो? बघा, कॉन्स्टंटचं डेरिव्हेटिव्ह 0 असतं, त्याचाच अर्थ L is constant. So this can be proved. म्हणजेच when statement बघा काय, when no external torque is acting on rotating body, its angular momentum remains constant. This is the principle of law of conservation of angular momentum. This is verified. 2 मार्क्सचा क्वेश्चन हा येऊ शकतो. स्टेट अँड प्रूव्ह law of conservation of angular momentum. Now, what are its applications? In our syllabus, there are 2 applications. First is ballet dancer. Ballet dancer is nothing but the dancer on rotating wheel, ज्याला आपण फ्लायव्हील म्हणतो. सर्क्युलर व्हील जे असतात त्याच्यावरती ते बॅलेट डान्सर जे असतात डान्स करताना रोटेटिंग व्हीलवरती. बघा या ठिकाणी फर्स्ट एक्झाम्पल ज्याला आपण म्हणतोय इज अ बॅलेट डान्सर. When ballet dancer is in that motion, see, there may be 2 positions. One will be like this, means when hands are outstretched, this is first position. Second may be like this, when hands are close to the body. What happens in this case? In this case, what happens? The moment of inertia of the body changes, and its effect is on angular velocity. In first position, we find that angular velocity is less In second position, its angular velocity is more. So what it indicates, when moment of inertia increases, the angular velocity decreases, and when moment of inertia decreases, angular velocity increases. So in that case, L is equal to I1 omega 1, their product, moment of inertia and angular velocity, that remains equal to I2 into omega. So this is nothing but law of conservation of angular momentum. So this is the product of moment of inertia and angular velocity. That product remains constant. When I decreases, omega increases. When I increases, omega decreases. This explains that the angular momentum of rotating body remains constant. This is for valid answer. Second one. Second one is for diving in swimming pool. Diving in a swimming pool. जे समजा एखादा स्विमर आहे स्विमिंग पूलमध्ये डाईव्ह मारतोय त्यावेळेस its hands are outstretched from the body. So what happens here? Its moment of inertia increases, and immediately after that, leaving the board, जिथे प्लॅटफॉर्मवर उडी मारताना they fold their body. This reduces the moment of inertia considerably, and the angular frequency or complete its position rounds in air so that it makes the fold and then jumps into the water. So what happens here? The when it jumps into the water, it stretches its body into streamline shape. So during the year, it should not get more resistance because its moment of inertia decreases in that case, and it can have a less moment of inertia. During when it jumps into the water, just at that momentum, what happens? He stretches the hands from the body, and it gets easier for that. So it finds a smooth entry into the water. Therefore, this also explains law of conservation of angular momentum. ओके आणि यातला जो काही लास्ट पार्ट जो आहे तो रोलिंग मोशन आपल्याला एक्सप्लेन करायची. रोलिंग मोशन मध्ये बघा काय रोलिंग मोशन जी असते, जर आपण फॅनच्या बाबतीत बोललं तर फॅन फक्त रोलिंग मोशन रोटेशनल मोशन परफॉर्म करतो. पण एखाद्या गाडीचं जे काही व्हील असतं ते रोटेशनल मोशन ॲज वेल ॲज ट्रान्सलेशनल मोशन दोघंही फॉलो करतात. सो रोलिंग मोशन इज अ कॉम्बिनेशन ऑफ rotational motion and translational motion. So in that case, when we consider about total kinetic energy of the body in a rolling motion, so we can have equation Ke rotational plus Ke translational. By definition, this will come, let this is equal to E. So that is 1 half I omega square plus, for translational motion it is 1 half m v square, and this v is equal to r omega square. So you can have this 1 half, sorry, v equal to r omega. So when put in here, this will be I omega square plus 1 half m r square v square. So this is the relation. Now when we come to this relation, this will be 1 half mv square when put here, and for this I omega, by definition, for this we put 1 half, this is m k square, and for omega the relation is v upon r, its square, plus this will put as it is this relation 1 half m p square, so that we can take common from this, and this will become 1 half is common in both, m is also common, then v square is also common. So what is here? 1 plus 1 for this, and this will be k square upon r square. This is rolling kinetic energy. Means it is a combination of kinetic energy of rotational motion as well as kinetic energy of translational motion is in this form, where r is radius of that circular body or whatever may be, and this k is radius of gyration. So in that case, this formula comes 1 half mv square. This is linear velocity, 1 plus k square upon r square. This is the expression for energy of the rolling body. Now, in this, the next point we have to explain, that is what is the equation for linear velocity and acceleration that we have to find. To show this rolling motion here, just see the figure. This will be the slope, horizontal direction. Here it is height from this horizontal direction, and this plane is inclined through an angle theta. Now, when this body is released from this, it gets rolled down and comes at this position through this distance s. At this top position, it has a potential energy totally, that gets converted into the kinetic energy, and at this situation, lowermost position, it has purely kinetic energy. So total potential energy gets converted into kinetic energy. आत्ताच्याच मागच्या टॉपिकमध्ये आपण जे बघितलं आहे रोलिंग मोशनसाठी जे काही कायनेटिक एनर्जीचा जो फॉर्म्युला आहे 1/2 एम व्ही स्क्वेअर इंटू द ब्रॅकेट 1 प्लस के स्क्वेअर अपॉन आर स्क्वेअर. Now potential energy by definition is nothing but mgh. Suppose this is equation number 1. From figure, what is the value of this h? H is nothing but say this is opposite side, so it will be s sine theta. Okay, putting this value, you can have potential energy is equal to mg into s sine theta. Equation number 2. So here, when you put these values, or you can have this one. By law of conservation of energy, this potential energy is equal to kinetic energy, and when you put these values, mth is equal to 1/2 m v square into bracket 1 plus k square upon r square. Here this gets cancelled. आपल्याला एक लक्षात ठेवायचं की v चा रिलेशन पाहिजे तर हा v आपल्याला त्या ठिकाणी मिळवायचा आहे. So what will be, this 2 will come here, twice gh upon this 1 plus k square upon r square is equal to v square. जर आपल्याला वेलोसिटीचं रिलेशन पाहिजे, so taking root of this side, so v is equal to square root of twice gh upon 1 plus k square upon r square. This is the equation for linear velocity of the rolling body. Now again we have to find the equation for acceleration, linear acceleration. Now for this purpose we use third kinematical equation. Third kinematical equation is v square is equal to u square plus twice as. So from this we can have twice as is equal to v square minus u square, or a is equal to v square minus u square upon twice s. So in this figure, sin theta is equal to h upon s. So s is equal to h upon sin theta. Now using the values for v square, now initially first of all, when body is at this top position, this factor is 0. So substituting value for v square, that is twice gh whole divided by 1 plus k square upon r square 2 into h upon sine theta. So simplifying this factor, you can have twice gh upon 1 plus k square upon r square into, this will get inverted, sin theta upon 2h. Now here hh gets cancelled, 2 gets cancelled, and what is remaining? G sin theta upon 1 plus k square upon r square. This is for linear acceleration. So this is the expression for linear acceleration when body is rolling. So in this topic we discussed about what is the rolling motion, what is its kinetic energy, then the equation for linear velocity and linear acceleration. So in this way, here this factor plays the role 1 plus k square upon r square, here in both expressions. So here radius of gyration and its radius, that plays very important. It has an effect on this both variables, linear velocity as well as linear acceleration. Okay, thank you.